Hello everyone, welcome to my channel Learn the Ropes. In the last session we have seen the basic concepts, right? Before starting the electrostatics, the first chapter, that is electric charges and fields, we have seen the most important basic concepts. First we have seen how to take the graphs, how to plot the graphs. Suppose there is an equation y equal to mx plus c, there is a straight line graph. How exactly we are taking the straight line graph? Where m is the slope, c is the intercept, right? So c equal to 0 we are taking from the origin. If c equal to some value we are taking from the value. Where m is a slope, it is a straight line graph, right? So after that we have seen the equation x square by e square plus y square by b square equals to 1, right? So in the x square by e square plus y square by b square equals to 1, it is an ellipse graph. We are plotting the ellipse graph. So when a greater than b, how exactly we are plotting the graph? When b greater than a, how exactly we are plotting the graph? We have seen that. After that, we have seen the circle x square plus y square equal to e square, where e is the radius part. It is a circle a. We are taking the radius x and y. We are plotting the graph with respect to circle. Then we have seen xy equal to constant, that is a rectangular hyperbola, correct? How to take the infinite to 0 value? If xy equal to c, x equal to c by y equal to 0, x equal to infinity, x equal to 0, y equal to infinity. How exactly we are plotting rectangular hyperbola? We have seen the most important part, that is x equal to y square, y equal to x square. When the power is 1, another power is 2, maximum power is 2, then we are plotting the graph with respect to parabola, correct? No, y equal to x square, x equal to y square. When exactly we have to take negative value, when exactly we have to take positive value, where exactly y becoming negative, y becoming positive, x becoming negative, x becoming positive, all those things we have seen. Y equal to x square, x equal to y square, y equal to minus x square, x equal to minus y square, right? After that, we have seen the basic concepts related to the vectors. In the vector part, we have seen how to add two vectors. See, suppose say if we are adding two scalar physical quantities, we will add with respect to simple algebraic addition. If we are going with the vector physical quantities, we have to add those two vectors using some rules, some laws. Those laws we are calling it as a triangular law of vector addition and parallelogram law of vector addition. In the triangular law of vector addition, we are taking it as a head to tail method. In the parallelogram law of vector addition, we are taking it as a tail to tail method. In the last class, we have seen, suppose say a person moving in the east direction, 3 meter in the east direction, then he goes in this direction making angle 60 degree. Correct now? Suppose it is taking 4 meter. Then if I ask what is the displacement he reached, displacement is a vector physical quantity. Now this is the resultant we are getting. Correct now? What is the resultant we are getting? R equal to under root a square plus b square plus 2ab cos theta. To understand the direction, I have to tan theta. See, don't confuse here. This is the theta 60 degree. To understand the direction of a resultant, we are taking this theta. Suppose say we are taking alpha. Correct? So now tan alpha equal to b sin theta divided by a plus b cos theta. This is how exactly we are trying to understand the direction of a resultant. Don't confuse with this theta and this theta. This is alpha or theta with respect to direction. Understood? So now after that we have seen what is parallelogram law of tradition, that is a tail to tail method, right? So in the tail to tail method, if we are taking one vector physical quantity in this direction, another vector physical quantity in this direction, the diagonal part we are giving the resultant no, the theta we are taking it as a some angle. From the alpha we are calculating what is the resultant direction. Understood? So now, after that, the main important concept we have seen, that is resolution of vectors. How we are breaking the components in terms of vector physical quantity. Suppose say, if it is a vector physical quantity, let's say the block, there is a block, we are pulling it with one force making angle theta. See, if I am applying a force, external force making angle theta, then we how to break the components in the horizontal component and the vertical component. We have seen some different examples with respect to breaking the components. Correct? So now after that we have seen the multiplication of vectors. Vector multiplied by vector, which is giving scalar physical quantity, we are calling it as a dot product. Work is a best example. Force and displacement. When you apply a force, it has gone some displacement. When vector multiplied by vector which is giving scalar physical quantity, we are taking cos theta angle between them. Correct now? After that, we are seeing vector multiplied by vector which is giving scalar physical quantity. We are taking it as a vector product or cross product, that is with respect to multiplication of vectors. We'll see that in terms of some values, some numericals, right? After that, we have seen the main concept, that is conservative force and non-conservative force. Conservative and non-conservative is very important. The conservative forces are the four forces, that is gravitational force, electrostatic force, magnetic force and spring force. Whenever we are doing the work done against the conservative force or in terms of the conservative force, it is storing as a change in the potential energy. Positive and negative, we'll say that later, right? So now in the conservative force we have seen two important notes, that is first one, work done by conservative force does not depend upon the path, it is depending upon only initial and final position of the body. What I mean by this, suppose say this pen has been taken to the maximum height, h maximum height. Suppose say if I am taking in this path or in this path or in this path, in any path, work done remains same with respect to conservative force. The second part, we have seen work done by conservative force around the round trip is always equal to 0. Suppose say if we are taking this pen to the maximum height A to B point, again B to A point, work done is 0 around the round trip. These are these concepts we have seen in the conservative force, but non-conservative force ulta. So when work done around the round trip is not 0, it is depending upon the path. Understood? Okay, so now all these basic concepts we have seen before starting electrostatics. Now we will start electrostatics part, right? Now in the electrostatics, electrostatics. See, electro means charge. Electro means charge. Static means rest condition. Understood? So electrostatic part, it is a branch of physics which deals with the charges are at rest condition. What do I mean by electrodynamics? Electrodynamics is, it is a branch of physics which deals with the charges are in moving condition. Now we will start dealing with electrostatics. In the electrostatic, the chapter we will start, that is electric charges, electric charges and fields. Electric charges and fields. This chapter we will start in the electrostatics, right? So now in the electrostatic, what exactly we are going through, what concepts we are studying here, so we'll see one by one. The first, we will see what I mean by charges. What do I mean by charges? In the charges, we will see the concepts, the properties of a charge, the properties of a charge, and the second concept, that is methods of charging. Methods of charging, right? The second one we will see the most important, that is Coulomb's law. Coulomb's law, right? In the Coulomb's law, we will see some different cases. First, we will see different cases with respect to JEE and NEET. Then, we will see the Coulomb's law in the vector form. In the vector form. And also, we will see here what do you mean by superposition principle. We will see what do you mean by superposition principle. All these things we will see in terms of the Coulomb's law. The third we will see, the third concept we will see what do you mean by electric field. What do you mean by electric field? In the electric field, we will see different cases in the electric field, and we will see what do you mean by electric field lines. Electric field lines, right? Now, in the fourth part, we will see what do you mean by electric dipole. Electric dipole. In the electric dipole, we will see what do you mean by dipole moment. What do you mean by dipole moment? Then we will see the electric field. EF means electric field. Electric field due to dipole at axial point and equatorial point. equatorial point, and the third one is general point. General, we'll see this later. In the electric dipole, we are finding what is the electric field due to dipole at axial point, at equatorial point, and at general point. Now the fifth concept, we will see what they mean by electric flux. What they mean by electric flux. And the last one, we will see what I mean by Gauss's law and its applications in Gauss's law. All these concepts we will see in the electric charges and fields. Understood? So these concepts we are seeing in the electric charges and fields. One by one we will see with respect to theory, with respect to NEET, with respect to JEE mains as well. Understood? Okay, so now let's start defining a charge. What do you mean by charge? You people already have studied in the 10th class. What do you mean by charge? Right? What do you mean by current? I equal to Q by T. What do you mean by Ohm's law? All those things you have studied already. Now we will start dealing with charge. So basically we are defining the charge, that is charge is a intrinsic property. Charge is intrinsic property of a matter. Charge is basically intrinsic property of a matter due to which it attracts or repels another matter. See, this is the basic definition of a charge. What do you mean by charge? Charge is an intrinsic property of a matter due to which it attracts or repels another matter. What do you mean by intrinsic? Intrinsic matlab basic. It is a basic property of a matter due to which it attracts or repels another matter. We already know that like charges repel each other, and unlike charges attract each other. Right? Suppose let's say there is a plus q charge, and another there is a plus q charge. It is separated by some distance. Correct? See here, these two charges are like charges. Hence, there is an electrostatic force of attraction. Electrostatic force of a repulsion. Simply, we will take it as a repulsion. Suppose there is a minus q and there is a minus q charge. Again, here there is a repulsion. Like charges repel each other, unlike charges attract each other. Suppose let's say we are taking plus q charge and here we are taking minus q charge. See, these are the unlike charges too, the plus q charge and minus q charge. These two charges will attract each other. Simply we are taking it as a like charges repel each other and unlike charges attract each other. Now the next point, that is the three most common elementary particles are proton, neutron and electron. Proton, neutron and electron. The three most common element particles are proton, neutron and electron. Suppose let's say in the nucleus, this is a nucleus, right? In the nucleus, we already know that there are number of protons and number of neutrons are present, where the electron is revolving around the nucleus. Correct? No? This is the electron is revolving around the nucleus. So now this positive charge we are calling it as a proton, and this we are calling it as a neutron. Where proton is a positively charged, neutron has no charge. It is having no charge, and electron is having negative charge. This we are calling it as a electron. Correct now? So this we are calling it as a structure of atom. We are calling it as a structure of atom. Correct? So now in the charge we have seen 3 points. First is a definition, how exactly like charges repel each other, unlike charges attract each other. Next point, the three most common elementary particles are proton, neutron and electron. Now, in the structure of an atom, we already know that nucleus is present at the center of an atom, which is containing neutrons and the protons. Protons are a positively charged, neutrons has a no charge, and electron has a negatively charged. Hence, if I ask what is the mass of an electron, mass of sorry for the disturbance. So we'll continue the concepts. Okay, so now if I ask what is the mass of an electron, mass of electron, we will say it is equal to 9.1 into 10 to the power minus 31 kg. If I say what is the mass of proton, mass of a proton equals to 1.672 into 10 to the power minus 27 kg. Mass of a neutron, mass of neutron is equals to 1.674 into 10 to the power minus 27 kg. See here, mass of a proton is almost equal to mass of a neutron, but the mass of a neutron, we can say that mass of a neutron slightly greater than mass of a proton. Slightly, it is slightly greater than mass of a proton. Correct? So now if I ask what is the charge of an electron? Charge of an electron. See, charge of electron is negative. So now we will say minus 1.6 into 10 to the power minus 19 coulomb. If I ask what is the charge of a proton? Charge of a proton, it is positively charged, but the magnitude is same as of an electron, plus 1.6 into 10 to the power minus 19 coulomb. Now tell me what is the charge of a neutron? What is the charge of a neutron? There is no charge, no. Charge of a neutron is Simply we are taking it as a 0. Understood? So now this is the basic definition of a charge, basic concepts of a charge. Please note down. Okay, so the next concept we will see what is the origin of a charge. How exactly charge has been originated. See, origin of origin of origin of electric charge. Origin of electric charge by friction. By friction. How exactly electric charge has been originated? We have to see this. Here we are doing some experiments. See here. When two bodies rubbed against each other, then electrons will be transferred. Understood? We'll see that. When two bodies rubbed against each other, electrons can be transferred from the atom with the less affinity in the outermost orbit of electrons to the more affinity of the more affinity with the outermost orbit of electrons. Understood? I will repeat it. See here. When two bodies rubbed against each other, electron will transferred with the atom where it is in the outermost less affinity of outermost orbit of an electrons to the more affinity of the outermost orbit of electrons. What do I mean by this? Suppose let's say there is a glass rod. Let's say this is a glass rod. It is a glass rod which has in the neutral condition number of protons equal to number of electrons. इसका मतलब क्या है? It is in the neutral condition. It is in the neutral condition. Now, if I take a silk cloth, this is a silk cloth. It is also in the neutral condition. This is a silk cloth. This setup we are calling it as a before rubbing part. Before rubbing. Now, if I rub this silk cloth to the glass rod, where when we are rubbing this silk cloth, suppose say it is having number of protons equal to number of electrons, it is also having number of protons equal to number of electrons. This is during rubbing. This is the during rubbing. When these two bodies rubbed against each other, then the electrons in the glass rod will be transferred to the silk cloth. Got my point? See here. When this silk cloth or glass rod rubbed against the silk cloth, the electrons in the glass rod are transferred to the silk cloth. When the electrons is transferring from the glass rod, there is a deficiency of electrons occurs in the glass rod. इसका मतलब क्या है? The glass rod becomes positively charged, where there is a gain of electrons in the silk cloth. This silk cloth becomes negatively charged. Understood? If I say after rubbing, what is the condition? This will be having positively charged. The glass rod becomes positively charged. This is a positively charged body. Now the silk cloth, after rubbing, already it has number of protons equal to number of electrons. These electrons from the glass rod transfer to the silk cloth. Hence, there is a gain of electrons on the silk cloth. So this silk cloth becomes negatively charged. This becomes negatively charged body. This is how exactly the origin of a charge is existing through the friction. Understood? See here. Whenever there is a loss of electrons, that body becomes positively charged. Whenever there is a gain of electrons, that body becomes a negatively charged. Understood? When the glass rod rubbed in the silk cloth, the glass rod becomes positively charged, the silk cloth becomes negatively charged. we will see some important table which body rubbed against each other, which is getting positively charged, which is getting negatively charged. When the glass rod, rubbed with the silk cloth, then the cat skin rubbed with the ebonite rod, and next the woolen cloth rubbed with the amber rod, and the last one, the woolen coat rubbed with the plastic rod. Plastic rod. See, whenever these two bodies rubbed against each other, the right side of the table gets positively charged, and this one gets negatively charged. इसका मतलब क्या है? Negatively charged. Understood? इसका मतलब, see here, when the glass rod rubbed with the silk cloth, the electrons transferred from the glass rod to the silk cloth. When the cat skin rubbed with the ebonite rod, the electrons from the cat skin transferring to the ebonite rod. So this ebonite rod is having gain of electrons. Hence, this becomes negatively charged. This is the deficiency of electrons or losing the electrons. This becomes the positively charged. The same condition applies from the woolen coat when rubbed with the amber rod and plastic rod. Understood? So this we need to remember how exactly we are originating the charge through the friction. When two bodies rubbed against each other, how exactly it is becoming positively charged, how exactly it is becoming negatively charged. See here, we have to understand the concept here. Whenever we are rubbing the glass rod with the silk cloth, whatever the total charge we have before rubbing, the same total charge is existing after rubbing also. Charge neither be created nor destroyed. Understood? Charge neither be created here nor be destroyed. Only it is transferring from one body to another body. This we are calling it as a conservation of charge. Understood? This is one of the most important property of the charge. Charge neither be created nor be destroyed. It always remains constant in an isolated system. This we are calling it as a conservation of a charge. We will study in the properties of a charge. What do we mean by conservation of a charge? Understood? So now the next concept we will see what do you mean by conductors. What do you mean by conductors? Right? So now conductors are these are the materials which allow charges through them. See here, whenever the material is allowing charges through them, no, we are calling it as a simply conductors. Right? Now, the second point we are writing as silver is a best conductor. Silver is a best conductor and it is also costly. Right? The next point we are writing it as suppose the examples of a conductors are copper, iron, aluminium, etc. See, these are the best examples of the conductor. The next point we are writing as earth is a good conductor. Earth is a good conductor. Earth is a good conductor and it contains ocean of electrons. This is important. It contains ocean of electrons. The last point we are writing human body is also good conductor. Human body is also a good conductor. Right? See here. These are the materials which allow charges through them. Silver is the best conductor. The other examples, copper, iron, aluminium, etc. Earth is a good conductor. See here. Basically, Earth is a reservoir of electrons. We are telling it as an ocean of electrons. It is containing ocean of electrons. See, in our house, the fridge socket, we are having three sockets now. Why three sockets? One socket is connected to the earthing part. That how exactly we are explaining that. See, whenever there is a earthing happens, the electrons transfer to the earth, or electrons will come to the material. See, whenever the high voltage comes to the fridge, whenever the high voltage comes to the fridge, the excess of a charge will go to the earth. That's why we are not getting the shock. Understood? That's why we are calling it as a earth is a good conductor, and it contains ocean of electrons. It is a reservoir of electrons, and human body is also a good conductor. Now, what do I mean by insulator? Insulator. Insulator, these are the materials. These are the materials, materials which does not, which does not allow charges through them, which does not allow charges through them. Correct now? So when the charge is not allowing in the material, those materials we are calling it as a insulator. What are the examples? Examples are plastic, paper, paper, rubber, etc. Correct now? So these are the some best examples of the insulator. Insulator, insulators are also called dielectrics. We are calling insulator, we are calling also it as a dielectrics. Understood? So what we have seen, what do I mean by origin of electric charge by friction? When two bodies rub against each other, how exactly electrons are transferring from the less affinity to the more affinity in the outermost orbit of electrons? How exactly the electrons is transferring? If the gain of electrons, it becomes negatively charged. If the loss of electrons, it becomes positively charged. These are the some examples how exactly we are rubbing two bodies, then which one is getting negatively charged, which one getting is positively charged. Now what do I mean by conductors, what do I mean by insulator? We have to remember that is earth is a good conductor and it contains ocean of electrons. And what I mean by earthing? Earthing concept we will see later how exactly we are earthing.